right. To start our video today, we're going to take a look at this problem. And we are currently in section 1.5 of the calculus textbook. And as we look at this problem, which has been on a few webassigns and has shown up on Albert, we need to make sure we understand what's being asked. So if you just take a minute, pause the video, and see if you can determine what to do. And if you get stuck, unpause the video. I'm going to give a couple hints, but try it on your own first. Okay, so if you're needing a hint, one of the things we need to do to make it continuous, we need to make sure there's no jump discontinuity at 2, which is where one function takes over for the other. So one first hint would be to plug in 2 to both equations for x. Go ahead and try that. Pause the video again. If you're back for another hint, I'm going to go ahead and start writing now for this hint. So like I said, we're going to be plugging in 2. So we're going to have a times 2 squared, which is equal to 4a. And then over here, we've got 2 minus 3, which is -1. And we want there to be no jumping. So what we're going to do now is set these two equal to each other. And so 4a is equal to -1. And so a has to be -1/4. And that's it. What should happen now is if we were to go to, say, Desmos and graph this with -1/4 in for a, we would see that there is no gap. In this picture, I've got what I haven't typed in these two equations into Desmos, and you can see with a being -1/4, there's no gap. They meet right here. The line takes over for the quadratic, and there's no gap, and therefore it is continuous. Okay, so as we, what we're going to be talking about today is infinite limits. So that's what section 1.5 is about, is what happens to limits as infinity gets involved. We know that infinity means either a very, very large number or a very, very small number, bigger than we can comprehend. There is no largest number. There's a largest number with a name. But if you pick the biggest number you can think of, I can pick a number bigger than it by either just adding 1 to your number or times your number by 12 or whatever. So just something to think about. So, but first let's go ahead and just review what we know. Here is an equation. We're going to find the limit of this fraction 1 over x minus 3 as x approaches 3. We know that when we plug 3 in directly, we get 1 over 0, which does not exist. So we continue, and this is what the graph looks like. So if we considered the limit as we approach from the right, we are approaching positive infinity, and the limit as we approach from the left, we're approaching negative infinity. So that's what's happening in this picture, which is of course why the limit does not exist to this function. So we know that the limit doesn't exist because we're approaching two different numbers. One here on the right as we approach this way, we're going up to positive infinity. And again here on the left as we approach this way, we're going down to negative infinity. And so our limit does not exist. Okay, so we've done this before. We've talked about this particular situation a few times, but what happens if we're only doing it one-sided, as I mentioned? So if I approach from the left, which is what this -3 to the negative means, just means approaching 3 from the left. That's how you read that. We're going to 3, and we can see we're shooting off the screen down here to negative infinity. And so that limit is negative infinity. But as we approach from the right, we're shooting up to positive infinity, and so that limit is infinity. Now, infinity is still just an imaginary concept that was made up to describe something very, very large. We can't actually get to infinity. We can't actually make it there, and therefore you could also technically say that this limit doesn't exist. But we want to know that you notice as you go from the left that we're getting really, really small. And as we come from the right, we're getting really, really big. That's very important. It's the real reason why the limit doesn't exist. And so while you might be able to say does not exist, negative infinity is what we prefer on these, and positive infinity. So what about this one? So this picture is a little bit off our screen, so let me just kind of center it a little bit better. So as we look down here, we're finding the limit as up to process -5 of 1 over x plus 5 quantity squared. Again, if we plug -5 in, if we did direct evaluation, we would get 1 over 0. But as we look at this graph, we can see that both sides are going to infinity, and positive infinity, and this limit doesn't exist. And so what does that mean? What about the one-sided limits? So both, we would say that approaching from the left, we're going to positive infinity. Approaching from the right, we're going to positive infinity. And so they're equal, which normally means that the limit exists when the left-handed and right-handed limits agree. But in this case, we would say the limit doesn't exist, even though we can say it exists, but because we can't actually make it to infinity, the limit does not exist because we can't really get there. We would talk about the one-sided limits going off to infinity, meaning getting very, very large, but we wouldn't say the limit's equal to infinity because that still doesn't make sense. We're saying it's going to infinity. You can't really get there. So kind of the idea here. Okay, so let's take a look at this piecewise function. And we know at 3 that there's a hole in this graph. And we're not defining the graph at 3. We're leaving that open. And so this is its picture. So we've got our quadratic equation starting at 9, stopping at 9, going from this side to that side, and stopping at 9. And then we've got our rational equations taking over at its asymptote and going from that point forward. So if we look at our left-handed and right-handed limits, tell me what you think about what you know about the right-handed limit. Can you picture the right-handed limit that's this way, where it's going? So we're talking about the limit as x approaches 3 from the right of, and since I'm approaching from the right, that's this side. So I'm just going to go ahead and write that down and what's happening there. So think about that for just a minute. What's going on? That's approaching infinity. If we think about our left-handed limit over here, the limit as x approaches 3 from the left, and then that one is this limit up here. That's x squared, and where are we headed? And we are heading to 9. And so what would we say about the whole limit process? Does it say? I advanced one too far, so let's go back here. We would say that this limit does not exist because, again, the two don't agree. If we look at the two half limits, we can come up with two different answers for each part. Okay, so looking at this one with a vertical asymptote, that's the kind of limits we have sometimes when we're talking about infinite limits. We're usually talking about asymptotes happening, either vertical or horizontal asymptotes. So with our vertical asymptote, we have this beautiful picture we've already talked about. And we've got our left-handed limit, which is getting small forever, so negative infinity. Our right-handed limit, which is getting large forever, and the asymptote is what's causing that. Of course, dividing by 0 often causes asymptotes to occur. What is happening with this particular picture? So if we think about this, what's happening? We're approaching 0, which we can't reach because then we divide by 0. So what's happening with this limit? Let's go back and talk about that one for just a minute. So can we figure out where the asymptote is? Is there an asymptote there, or is there a hole? Is kind of the thoughts. Now this is not in standard form. It kind of is actually if you think about it. We've got 1 over x, which is our standard, this pretty thing, this graph that we've hopefully figured out from our past times together. And the whole graph has been shifted up 1, meaning that now it's my asymptote moved from the y-axis to being up here. So what's happening to that limit? I want you to make a decision about that, and we will talk about it the next time I see you. So I'm not going to tell you the answer. Write down what you think it is. And we'll talk about it later. And then there's this one. So again, what's happening, and this is a one-sided limit, and one-sided limits tend to exist. So if it's getting small forever, we say it's going to negative infinity. If it's getting large forever, we say it's going to positive infinity. So we rarely say that a one-sided limit does not exist. You can with infinity, but it's important to talk about what's going on with the picture. So again, I want you to kind of stop and think about this. We're dividing by cotangent, and cotangent has some asymptotes itself. It's a pretty complicated little problem. And again, we will talk about it next time. So come up with your own picture. Maybe take a look at the graph on Desmos of what the thing looks like, or try by talking with each other what you think might be happening with this one. And we will talk about it the next time I see you. That is all. So we will talk again. We'll be talking the next time about this limit and this one. This one's a little bit clearer because I gave you a picture. This one, I want you to go look at the picture yourself and come up with your own idea. It's a one-sided limit, so it definitely exists. We just got to figure out what it is. This one was not a one-sided limit, so decide what you think. And we will talk about this one specifically the next time I see you. Have a good day.